Hello and welcome to another video for pre-calculus. In this video, we are going to discuss about polynomial functions and their graphs. So we saw that in the previous video as well, the definition of polynomial function. So any function written in this form right here is a polynomial function where the coefficients are real numbers and the exponents are whole numbers. So the largest or the highest exponent in the function is the degree of the polynomial. So there's a small chart here that we can use to determine the end behavior of the graph of the polynomial function. So when we say end behavior, it means when x grows arbitrarily large. Okay, so when x becomes really large or when x approaches infinity, where does the function go to? And then similarly, when x goes to negative infinity, where does the function head to? So that's what we are saying when we say the end behavior of the function. So here, this chart says there are four possibilities that could happen. The first one is if the degree, so n is the degree of the polynomial. So if the degree of the polynomial is even or odd, this is saying the leading coefficient. Okay, so the leading, so for example, if our function is f of x equals 3x to the fourth plus 5x plus, let's say, 7. So here the degree is 4, so this is n, and this is the coefficient of the leading term, so this is a sub n. Okay, so this says that if n is even and the leading coefficient is positive, the graph of the function looks like this. So that means the end points of the graph or the end behavior is heading towards infinity. This is not going to tell us what happens here at the middle of the graph. I mean, how many turning points we have, how many x or y intercepts we have. It's not going to tell anything about that. Okay. What this chart tells us is as x approaches to infinity and x approaches to negative infinity, what happens to the graph? That's what this chart is telling us. Okay, so let's interpret this one. So the first one is if the degree is even and the leading coefficient is positive, this is how the graph looks like. Or this means, so here's an example. So we have even degree and positive coefficient. So in that case, as x approaches infinity, when x goes to infinity, the function also goes to infinity. So f of x also goes to infinity. Similarly, when x goes to negative infinity, so as x approaches negative infinity, the function goes to infinity. So f of x goes to infinity. Similarly, if the exponent is even but the leading coefficient is negative, then this is how the graph looks like. The end points of the graph are going to the negative infinity. So this means when x approaches infinity, the function approaches negative infinity. And similarly, when x approaches negative infinity, the function goes to negative infinity. Similarly, if the exponent, if the degree is odd, so here, if your function is f of x equals, let's say 5x to the 7th plus 2x squared plus 9. So if the degree is odd and if the leading coefficient is positive, this is how the graph looks like. So it means when x goes to infinity, the function also goes to infinity. When x goes to negative infinity, the function also goes to negative infinity. When it is odd and the leading coefficient is negative, it's the other way. So when x goes to infinity, the function goes to negative infinity. And when x goes to negative infinity, the function goes to infinity. So that's what this chart tells us. It is very helpful when we are graphing a function. And this gives us a lot of information. Okay, we'll be using this here. So let's look at the first example. It says determine the end behavior of each of the following function. So the first one, what we are going to do is we are going to use that end behavior chart. Okay, so here the degree is even and the leading coefficient is positive. That means the graph looks like this. That means when x goes to infinity and negative infinity, so we can say that as x approaches infinity, when x goes to infinity, the function goes to infinity. So f of x approaches infinity. As x approaches negative infinity, the function goes to infinity. So f of x approaches infinity. Similarly here, we have the odd degree, and then we have the positive coefficient. That means the graph looks like this. So which means as x goes to infinity, the function goes to, as x approaches infinity, f of x approaches infinity. It goes to infinity, okay? As x approaches negative infinity, f of x approaches negative infinity. So when x goes to negative infinity, the function also goes to negative infinity. Similarly here, we have the even power and the negative coefficient. So that means this graph looks like this, which means as x goes to infinity, the function goes to negative infinity. So as x approaches infinity, f of x approaches negative infinity. Similarly, as x approaches negative infinity, the function still goes to negative infinity. So as x approaches negative infinity, f of x approaches negative infinity. Similarly here, we have the odd power and the negative coefficient. That means the graph looks like this. Okay, so which means, so if we have, this is x goes to infinity, this is x goes to negative infinity. So here, as x approaches infinity, f of x approaches negative infinity. So when x goes to infinity, the function goes to negative infinity. Similarly, as x approaches negative infinity, the function approaches infinity. So when x goes to negative infinity, the function goes up. So those are the end behavior of the function, polynomial function, and this is helpful when we are trying to graph the function. Okay. So the next one is the zeros of the polynomial function. So zeros means the x-intercept. Okay. So if we have a polynomial function here, the zeros of the polynomial function is given by solving this equation. So if we set the polynomial function equals to 0, and then if we solve this equation, that gives us this 0. There are two things that are true. The first one is a polynomial of degree n can have at most n zeros. That's the maximum. So if the polynomial is degree 2, which is quadratic, the maximum number of zeros, possible zeros are 2. Okay, so if it's degree 3, the maximum possible zeros is 3. Similar, so that's the number of zeros. Okay, that's maximum possible. It could have less than that, but that's the maximum possible. Similarly, a polynomial function of degree n can have at most n minus 1 turning point. So for example, quadratic function, it is degree 2, so we have one turning point, whether it's facing down or up. Okay. Similarly, cubic function could have at most 3 turning points. It's again at most. It could have just one. It could have no turning point, but the maximum possible is n minus 1. So cubic function could have 2 turning points. Quadratic could have 1 turning point. Fourth degree function, the quadratic function could have 3 turning points. So it is 1 less than degree. Okay. Then there's another important term called multiplicity of 0. That means when we factor a polynomial function, if we get a factor in the form ax minus a to the some power m. Okay, so for example, if we have x minus 2 to the third, then we have x plus 4. So if these are the factors of the polynomial, so this is what m means, this number here. Then we say that x equals a is a 0 of multiplicity m. That means that 0 is repeating n times. It's kind of like repeated 0. Same thing here. If we solve this equals to 0, then we get x equals 2 as one of the zeros, but the multiplicity for this one is 3. That means that 0 repeats 3 times, or that factor repeats 3 times. So okay, so when we add all the multiplicities, that gives us the degree of the polynomial. So why is that important? The multiplicity is important because if the multiplicity is odd, so when we graph, so these zeros are the x-intercepts. So if the multiplicity is odd, so the graph will cross the x-axis at that 0. If the multiplicity is even, the graph will touch and bounce back. For example, if the graph is coming this way, it will touch the 0 and bounce back if it is even. If the multiplicity is odd, it's not the 0 odd or 0 even, okay? The multiplicity, if the multiplicity is odd, then the graph will cross the 0, okay? So that's why it's important when we are graphing, okay? So next example, we are going to look at how to graph a polynomial function. So in order to graph polynomial function, we need to find some of these things, okay? First, we need to figure out the end behavior. We'll use that chart, okay? And the second, we are going to find the zeros. So zeros are the x-intercept. They are the x coordinate of the x-intercept. So we'll put them on the x-axis. And then once we put those zeros on the x-axis, then we can pick a point between two zeros to figure out whether the graph will go above the x-axis or below the x-axis. So when we pick a point and plug it into our function, if we get a positive number, the graph will go above the x-axis. If we get a negative number, the graph will go below the x-axis. So that's what we'll do. The next thing, we'll find the y-intercept. Again, for the polynomial function, the constant term is the y-intercept. If it is given in factor form, we have to plug in x equals 0 to find the y-intercept. And then if necessary, if we want to get a better graph, we can use other multiple points to get a better shape of the graph or a more accurate graph. But at this point, we are just trying to draw this sketch, okay? So we are not going to draw exact graph. For that, we'll use technology, we'll use calculator to graph that. But we are just going to graph the shape, okay? So how does it look like? So we might not graph it exactly. And then we can also use the multiplicity in order to figure out whether the graph is going to cross the x-axis or is going to just touch and bounce back, okay? So that's what we'll see while we are graphing. So let's look at an example for that. So here is the polynomial function that we are going to graph. So the first thing is we are going to determine the end behavior. So in order to do that, we'll check the leading term. So the leading term is x to the fifth, and then this one has odd power, and the coefficient is positive. So that means we know the graph is going to look something like this, okay? Now the next thing is the end behavior. So as x approaches infinity, the function is going to infinity. As x approaches negative infinity, the function is going to negative infinity. So now we can write that as x approaches negative infinity, the function approaches negative infinity. Similarly, as x approaches infinity, the function approaches infinity. Now the next thing is we are going to find the zeros, and we are going to state what are the multiplicities of the zeros. So in order to find the zeros, we are going to state that function equals to 0, and we'll solve for x. Okay, so we have x to the fifth minus 2x to the fourth minus 4x cubed plus 8x squared equals 0. Now we can factor this by grouping. So what we are going to do is we'll group these two together and these two together. So from here we can factor out x to the fourth, and that gives us x minus 2. And then from here we can factor out 4x squared, and that gives us x minus 2 equals 0. Now the common factor is x minus 2, so we'll factor out x minus 2, and then we have x to the fourth minus 4x squared equals 0. So from here we get x minus 2 equals 0, which gives us x equals 2. So this is one of the zeros. Now from here we can factor out x squared, and we get x squared minus 4 equals 0. So from x squared equals 0, we get x equals 0. Here we get x squared equals 4, and that gives us x equals positive or negative 2. Now our zeros are, so the zeros for this polynomial are x equals 2, and then we have x equals 0, and then we have x equals -2. These are the zeros, okay? Now the multiplicity for them. So the multiplicity are, so if you look at 2, we have 2 here, and then we also get a positive 2 here. So we get two zeros that are 2, okay? So twice. That means this has a multiplicity of 2. Now if we look at 0, this is x squared equals 0. So the power is 2. That means the multiplicity is 2 for that one. And then we get x equals -2. There's only 1 0. So the multiplicity is 1. So now when we add the multiplicity, we get the degree of the polynomial, and we get that 2 plus 2 plus 1 is 5. Okay. Now we are going to graph the function. So first we are going to put the zeros into the graph. So the zeros are 2, 0, and -2. So -2 right here, 0 right here, and 2 right here. So these are the zeros or the x-intercept. Now here we know that as x approaches infinity, the function goes to infinity. So from here the function is going up. And then x approaches negative infinity, the function goes to negative infinity. So from here the function is going down. Okay. Again, we are just trying to draw this sketch of the graph. We are not going to draw an exact graph here. Now the next thing is we need to figure out what is the y-intercept. Now if I plug in x equals 0 into my function here, there's no constant term here, so we get 0. So the y-intercept is also just here, just at the origin. Now what we need to do is let's draw a number line here, okay? So our zeros are -2, 0, and 2. So this is -2, 0, it's -2, 0, and 2. Now let's pick a point between these two zeros. So from -2 to 0, let's pick a point here, which is -1. And if I plug in that point to my function, what do I get? So -1 to the fifth minus 2 times -1 to the fourth minus 4 times -1 cubed plus 8 times -1 squared. So when we do that, we get this is -1, this is -2, this is +4, and that is +8. So we get 8 plus 4, 12, minus 3. So we get 12 minus 3 is 9. That means we get +9. So here the sign is positive. That means function here goes up. Okay, I don't know exactly how far it goes, but it goes up here and then comes down to the other 0. Now at 0, see one thing here, at 0 the multiplicity is 2. That means it's not going to cross the x-axis. It will go back like this. But now we need to figure out how far does that go. Okay, so for that we'll pick a number between 0 and 2. Let's just pick a number 1 and then plug it into our function. Okay, so if we do that, 1 to the fifth minus 2 times 1 to the fourth minus 4 times 1 cubed plus 8 times 1 squared. Now when we simplify that, we'll get 3. That means at 1 function will go up here 3. So I don't know how far it goes. It might go above that for other values, but I'm just going to estimate it. It goes up here and comes down. And again at 2, the multiplicity is 2, so it's not going to cross, so it will just bounce back, and then we know that the graph is going to the infinity. Now for the other side, we really don't have to check because we already got that one. So the graph looks somewhat like that. It's not the exact graph, but that's how the overall shape of the graph looks like. Okay, so we'll just do this much for this video. I'll see you again in the next video.